All right, welcome back. Today's notes are going to start with some review, and then we'll jump into some new vocabulary and then some practice. So let's review what a point is. A point is just a dot. It has no size or dimension. It's always named with a capital letter. For example, we've got point A. A line is made up of at least 2 points. It may have more identified on that line. Any 2 points form a line. A line has no width or endpoints. We can name a line by any 2 points on the line or a lowercase script letter. For this example, we can name it line N. We can name it line XY. And remember, it goes on forever. Or we can just write out the word line XY. Collinear points are points that lie on the same line. Co meaning the same. When it's non-collinear points, these are points that are not going to be on the same line. Any 2 points always make up a line. So in this case, it must be at least 3 points to be non-collinear. A plane is a flat surface made up of points. Any 3 points make up a plane. A plane extends indefinitely in all directions. We name a plane by any 3 non-collinear points on the plane or an uppercase script letter. So we can name this plane P or plane, and then we just need any 3 letters. In this case, we've got the letters J, K, and L. Coplanar points, meaning they're on the same plane, and non-coplanar points, meaning they are not on the same plane. If you're talking about non-coplanar points, you must have at least 4 points to be non-coplanar, because any 3 will always make up a plane. 2 lines intersect at a point. So in this example, we've got point P where lines R and S intersect. 2 planes intersect at a line. In this case, we've got line K at the intersection of plane L and plane M. A line and a plane always intersect at a point. And I guess I should have labeled this one. Let's call this point M. Okay, I want you to pause the video and see if you can come up with some answers for number 1. Okay, let's fill in these answers. Number 1A, it says use the diagram to the right to name the following 4 collinear points. Collinear meaning they're on the same line. And if you're looking at this line R, it has 4 points on that line. So we'll call them H, N, K, and I. A line that contains point M. Okay, we're looking at this point M. We can name this several different ways. We can name this line P. We can name it MN, MO, NO. Those are some options. A line that contains points H and K. We can name it line R, HN, NK, KI. Lots of options for that one. Another name for line Q. Okay, line Q is this guy over here. So let's just name it with 2 points. How about JK or KL? We can also name it JL, as long as we have 2 points on that line. The intersections of line P and R. So we're looking at the intersection where lines P and R. Here's line P. Line R is in yellow, and they are intersecting right here at point N. Okay, pause the video and see if you can answer the questions on number 2. All right, number 2, a line containing point F. Point F is right over here, and we can identify this as line J, also DE, EF, or DF. Another name for line K, again, as long as you're picking 2 points on the line, I'll identify it as CE, but there are other options. A plane containing point A. All right, so now we're looking at this point A, and we can say, well, it's lying on plane M. I know this is identified as plane M because that's a capital script letter, so I'll just call it plane M. Or you identify it with 3 points. So points A, D, E, and F lie on plane M, so I just need to identify 3 of those. Oops. Don't call it point, but plane A, D, E. An example of 3 non-collinear points. So we need 3 points that are not on the same line. And we can use point B and then 2 other points that are on plane M, or we could use point C with 2 other points that are on plane M. So how about let's just identify B, A, and E. Now A and E are both on the plane. Point B is above the plane, so they are non-collinear. Letter E, the intersection of plane M and line K. Well, line K intersects plane M at point E. Okay, 2 more sections, so pause the video. Okay, let's try answering them. Number 3, it says use the diagram to the right to name the following 3 coplanar points. So we want 3 points that are on the same plane. We're looking at plane R, or we could look at plane WXZ. We also have this plane in the front, VWZ. We have a plane on the left side of this triangular pyramid, or a plane in the back. So pick your plane and identify 3 coplanar points. I'll go ahead and just identify points V, W, X. Those lie on plane R. Or I could identify Z, W, X, that lies on the yellow plane, or V, W, Z, that lie on the orange plane. A plane containing point X, okay, we can just say plane R. But we could also identify it as plane XWZ or XYZ. The intersection of plane R and plane ZVY. So ZVY is going to be this plane over here on the left side, and the intersection is where those 2 planes meet. They meet at this line VY. oops, I want to go ahead and take off the arrows because it does, since it is just a pyramid, this is a line segment, so let's rename it with just a segment on top. How many planes appear in the figure? Well, on this triangular pyramid, we have 4 planes. The yellow, the orange, the striped blue, and the one in the back. And then we also have plane R, so we've got 5 planes. How many planes contain point W? Okay, well W it's on plane R, and it is also a vertex on plane ZXW, and it's also a vertex on VWZ. So we've got 3 planes. And one last section. So pause the video, try to answer, and then come back. All right, number 4A, the intersection of lines L and M. Okay, line L is this guy, and line M is this guy, and where those two intersect, that is point E. Another name for plane Q, well, as long as we're identifying it with 3 points, plane 3 non-collinear points, that is F, E, and I. Are points D and E collinear or coplanar? Are they on the same line or in the same plane? So D is over here on plane P, and E is on plane Q. So they are on different planes, so they are non-coplanar, but they are on line L, so these are collinear. How many times do planes P and Q intersect? Well, these appear to be parallel, so I'm going to say never. All right, we've got some practice naming segments. In this diagram, we've got segments LM, LR, and MR. You have a little segment at the top of each of those. Let's name some rays. Now, we've got ray is we need an endpoint and a direction. So we can say this is ray LM, starting at point L, going in the direction of M, or we can extend that, and let's call that ray LR. Now we can come from the other direction. We can start at R and go in the direction of M, so we have ray RM. We can also extend that and identify that as ray RL. We can also identify ray ML. There's lots of ways. And I guess, well, no, we already got that one. So I think that's it. Parallel versus skew. Now this is the symbol for parallel. It's 2 little vertical lines. So we're looking for parallel lines in this case. So using this diagram over here, we want a pair of parallel lines. Parallel lines are lines that never intersect. So how about AB and EF? Skew lines are lines that are non-parallel and non-intersecting, non-coplanar and non-intersecting. So in this case, how about AB? And let's take a look at this guy back here. How about CG? Skew lines. These are non-coplanar and non-intersecting. Okay, let's go through some examples. Name 2 segments parallel to GJ. So GJ is in this back corner of this prism, and if we want to be parallel, we can identify, let's see, how about AD? Or HI. Two segments skew to GJ. Okay, so GJ, still back corner. So we want to be on a different plane and never intersecting. Okay, how about this guy? BH. You see how these guys, GJ, if I were to extend it forever, it's going vertically, but it's at the back of that prism. BH is going horizontally, and it's on the right side of the prism. We could also name a segment CI. That is skew to GJ. Number 3, name two segments perpendicular to GJ. When we see the word perpendicular, we mean they meet at a right angle. Now it looks like we have a right prism here. So GJ, if we're meeting at a right angle, how about JI? Or AG. Name two pairs of parallel planes. Okay, so how about the top and the bottom? We have a plane here. It is a flat top, and then we can say that it's going to be parallel to this bottom plane. If we extend those forever, they will never intersect. So how do we name planes with at least 3 points? So we can say plane ABH and plane DCI. Oops. Name two lines parallel to plane DJCI. So DJCI is this plane on the bottom that I've colored in orange, and we want two lines parallel. Well, a line parallel, how about AB and GH? And if we want lines, we need to have arrows on the ends. Now, we could also go in the other direction instead of going in the horizontal. Well, they're both horizontal, but we could be coming in this direction and say that AG is parallel to this plane as well as BH. So there are other options. Number 6, which pair of planes are parallel? Well, planes are identified with capital script letters, so we could say plane A and plane B. Name two planes that intersect. Intersecting at a line, how about A and C? Or we could also say B and C. Which planes intersect in segment MN? Okay, so here's segment MN, and so we can see that plane A and also plane C are going to intersect in segment MN. Which plane intersects in RS? Well, those are going to be the other two planes, and that would be plane B intersecting with plane C.